pressure law or gas Joules's law. Pressure law said that the pressure of a certain mass of a gas is directly proportional to its temperature at constant volume. Okay, this is number 1. Therefore, P1 over T1 equal P2 over T2, and as in case of volume and temperature, therefore the graph which represents this relation also it may be pressure and temperature in Kelvin scale. It is represented by a straight line, and also pressure and temperature in Celsius scale. It is represented by a straight line, doesn't reach to 0, and this point represents pressure at 0 Celsius. And also there is what is meant by experiment to prove that equal pressures of different gases expands equally when heated through the same temperature. When we put a flask, this flask contains amount of a gas, say it is carbon dioxide. We put inside it glass tube which is connected to a funnel to put mercury. And we put mark X to make the volume of the gas constant. This is mark X, and this is mercury. When we put the flask in a container contains hot water, we found that the volume will expand, causing the mercury level to lower down. We pour another amount of mercury to keep the volume constant. And then when the mercury reaches to mark X, we found that the mercury level increased in this branch. We found that the pressure will increase, by increasing the temperature. This is H, where the pressure in this case equal PA plus H. And we repeat the same experiment for all or for different gases. We found that they will expand with the same amount for the same amount of increase in temperature. So equal pressures of different gases expands equally when heated through the same interval of temperature. منها عرفنا البيتا P اللي هي pressure expansion coefficient. pressure expansion coefficient. pressure expansion coefficient. هلا اني برضو it is the same beta P equal increase in pressure per pressure at 0 Celsius for each increase in temperature by 1 degree Kelvin. And also they found that it is equal to 1/273 Kelvin -1 as volume expansion coefficient. Apparatus used to prove this is called Joules's apparatus. Joules's apparatus. We use a flask. This flask contains air enclosed in it. We put the flask and connect it to a glass tube which is connected to a rubber tube and a reservoir which can be moved easily. This is a reservoir that can be moved easily upward or downward. Then we put this flask in a container contains crushed ice to measure the pressure at 0 Celsius, and then we heat the flask and raise the temperature to 100 Celsius. This is thermometer to measure temperature of water to reach 100 Celsius. Therefore, beta B equal pressure at 100 Celsius minus pressure at 0 Celsius over pressure at 0 Celsius times delta T. Okay? We put inside the flask 1/7 mercury. Why? To compensate the increase in volume of flask, because the flask, its volume will increase by increasing temperature. So 1/7 of its volume is put mercury to compensate this increase, therefore keep the volume constant. And this is the mark X, which keeps the volume of the gas constant by moving this tube which contains mercury, okay, up and down until reaching to mark X. Therefore, the volume of the gas is still constant. Okay, this is called Joule apparatus. General gas law. General gas law. General gas law states that from Boyle's law, we said that volume is inversely proportional to pressure at constant temperature. At constant temperature. This is Boyle's law. And volume is directly proportional to temperature at constant pressure. This is Charles' law. Charles' law. Therefore, volume directly with temperature, inversely with pressure. Therefore, pressure times volume over T equal constant value. Okay, therefore P1 volume 1 over T1 equal P2 volume 2 over T2. Okay, this is a general gas law. And at STP or NTP means standard temperature and pressure or normal temperature and pressure. Okay, the temperature will be 273. Okay, 273, and pressure will be 1.013 times 10 power 5 Newton per meter square. Okay, and the volume will differ from gas to another gas. Well, good luck.